we're going to talk about the VSEPR theory. Okay, this is a continuation. The left one, the other left. Okay, this is a continuation of Lewis structures. Okay, and I have this recorded, and I will also post this video also. This is the VSEPR theory. It's a continuation. Remember, Lewis structures are 2D. Lewis structures are 2D, so now we're going to start turning things into 3D. The VSEPR theory stands for the valence shell electron pair repulsion. Okay, valence shell electron pair repulsion. It's used to predict the shape of the molecule and or the polarity. Okay, it has one main postulate. The main postulate says that the structure around a given atom is determined principally by minimizing electron pair repulsion, because we know that electrons have a negative charge. So we know electron pairs. We know that electron pairs are that way because of their spin numbers. Okay, we know that they stay together. The two electrons stay together because one, they're spinning in opposite directions. Okay, but we know that in a molecule, we could have up to three or three lone pairs of electrons. So we want to minimize all that repulsion. The key thing that postulate really says is electrons pairs want to be as far apart as possible. Okay, electron pairs want to be far apart as possible. That's what it says. VSEPR is the valence shell electron pair repulsion. So if you're repulsed, so you could say that like most people are repulsed by bogons, so they want to get as far away from the bogons as possible. So we put the bogons together. Okay, so that is the VSEPR theory. The lone pairs of electrons require more space than shared pairs. Okay, lone pairs require more space than shared pairs. And that's where we are with the VSEPR theory. The big thing in the VSEPR theory is we're going to determine the shape of the molecule. So rules for determining the shape of the polarity. The first thing, you're going to draw your Lewis structure. Okay, you're going to draw your Lewis structure. Second thing is you're going to count the number of electron pair groups surrounding the central atom. Key thing here is the number of lone pairs on the central atom. A common mistake is count the number of lone pairs total. Number three, determine electronic or molecular geometry that maximizes the distance between the groups. This is going to be looking at that chart I just gave you. Virtual Kids, I've also posted it on Google Classroom, okay, on the stream of Google Classroom.
I don't think there's anything on it, though. Or is that are those worksheets? That's a worksheet, too?
It's the best. Was the worksheet blank?
The molecular geometry.
Maybe internet was looking. We'll look at that more. Okay, I think I might have had some internet problems. But it says VSEPR on the pardon me, on your stream. It says the VSEPR chart, VSEPR handout 1 and 2. Fourth thing, you're going to determine the molecular geometry around the central atom. We're going to make sure you adjust for shared pairs. So we're really counting the number of lone electron pairs and the number of bonds to the central atom. And then number 5, we're going to determine if the molecule is polar or non-polar. I will tell you, when we go through this, we'll talk about polarity today as we work through simple. So those are our 5 steps. The key thing to this is, can you draw this Lewis structure? If you can draw the Lewis structure, this is one of the easiest things possibly to do. Okay? This is super easy to do if you can draw a Lewis structure. If you can't draw a Lewis structure, you're SOL. You can't draw, you can't determine the shape, you can't draw it. Okay? You can't determine the shape and you cannot draw it. Okay? My computer is being so slow. All right. So let's everybody got those 5 rules that we're writing? Okay. Let me know when you're finished. All right, so I want to draw. The instructions are going to say draw the shape of water. Okay, draw the shape of water. So our first step, so we want to do water. Oh man, that's way off. So we're going to draw water. Okay. So we need to draw the Lewis structure first. We know that water has A valence electrons, correct? Because water is H2O. A valence electrons. We'll put my O in. And O has 6. 1, 2, 3, 4, 5, 6. I can clearly put my 2 H's in, can't I? Mask over nose, Tommy. H there. H there. So this is the Lewis structure right here. Two questions when we're talking about shape or geometry. Okay, we're talking about geometry or shape, just however they want to do it. Is the two questions I'm going to ask is how many atoms are bonded. Let me get this correct exactly how it is on your handout. Bonded atoms and lone pairs. Okay. So in this, how many bonded to the central atom? How many bonded atoms do I have? 2. I have 2 atoms bonded to H, don't I? So that's 2. How many lone pairs do I have? 2. I have 1, 2. So what is the shape? What's 2, 2? We're looking at the molecular shape. Bent. Everyone see that? All right. So let me pull this up. I'm about to explain it. All right, so I'm gonna look at this chart right here, okay? And I'm really looking at, let me find my mouse again. I'm looking at these 2 columns right here. All right. I'm going down until I find 2 atoms bonded, okay? And 2 lone pairs, okay? So 2 atoms bonded, 2 lone pairs, it comes down here to this. Okay, I'm looking at the molecular shape. So this is my one right here, okay? Everyone, does that make sense to you, Brooklyn? I'm coming to that. Now, I want to draw this exactly. I asked you to draw the shape. I'm going to draw it exactly like it's drawn on there. Okay. What's the only difference going to be between this and my shape? I mean, this. This one uses A's and X's, doesn't it? Yeah. I'm going to use what? O's and H's. I'm going to draw it the exact same way. I'm going to draw it the exact same way, but instead of writing an A, I'm going to write a O. Instead of writing my X, I'm going to write an H. Okay? So I'm going to draw it the exact same way. These little circle things that are hard to see, those are the lone pairs of electrons. Okay? There's 2 dots in each one of those. So I'm going to draw it exactly. I'm going to draw it exactly like. I'm going to draw it exactly like it is on there. Two bits. My shape is bent, so I'm going to draw it exactly like it is on this. So, but instead of drawing my A with A's and O's, I'm going to draw it with, A's and X's. I'm going to draw it with H's and O's. And I have one more thing that I'm going to put on that part of it. So, yeah, the Lewis structure is regular. The Lewis structure is independent from the 3D structure, okay? So, my O was in the middle. I had an H going up, an H going this way to the side, dot, dot, in a circle, dot, dot, in a circle. Okay. Now, my last question to ask is this polar or non-polar? So polarity. Is it polar or non-polar? It's polar. We look at our electronegativity differences. It's 3.5 minus 2.1. And so it would be 3.5 minus 2.1. That equals 1.4. So it is polar. Periodic table. If I'm talking about polarity, I'm going to look at the electronegativity differences. I get that from the back of the periodic table.
You just go, like, you went for what, the second O?
Second H.
Oh, just second H.
Yes and no. I'm going to come back to that one in a second. Okay. Now, Marshall, are these pulling in the same direction? No. There's one pulling at this angle, one pulling at this angle. So they're not canceling each other out. We're going to come back to that in a second, okay? All right, let's go with CO2 now. We'll do all the same stuff for carbon dioxide. We'll draw the Lewis structure first. The Lewis structure first. So I know that carbon dioxide has what, 16 valence electrons? How someone tell me how carbon dioxide would look, the Lewis structure? See in the middle. No, not 6 around it. 4 around it. Darian said 6. And then O, 1, 2, 3, 4, 5, 6. O's, 1, 2, 3, 4, 5, 6. There's a bond, there's a bond. Any more bonds in it? Bottom one and there, okay? So it looks like that. So, my question I have is how many bonded atoms do I have? How many bonded atoms are on there? I have the answer. 2. Only have 2 atoms bonded to C, don't I? I have one O and then another O.
Oh, you mean like directly bonded to?
Yes, bonded directly to the C. Yes. How many lone pairs do I have? To the central atom. 0. There are no lone pairs in the central atom, are there? We know O has 2. O has 2, but I'm only talking about my central atom. 2, 0.
Wait, why is it couple numbers?
Because I have 4 bonds, okay, but I only have 2 atoms that are bonded, correct? That's a very common mistake.
Yeah, okay. So it's 2 because of the 2 that's like directly over
Yes.
the center.
Wait, those are directly to.
Which ones?
The top and bottom.
Yeah, but it's not the number. There's 4, 1, 2, 3, 4 bonds. But how many different elements are bonded to this C? This 1 O and that 2 O. Okay. All right. What's the shape?
Linear.
You went on the chart and you saw that 2, 0 was linear. So that 2, 0 was linear. So now I need to draw it. Instead of A, I'm going to write the A is going to become what? C. So I'm going to write my C. And then line. Oh. I do not need, when I'm drawing the 3D shape, you do not need to worry about the lone pairs of electrons on the O. Okay? I worry about the lone pair of electrons on the central atom, but not on the outside atoms. Okay?
So draw exactly how it is on your paper.
Yes, exactly how it is on the paper, just replacing the element.
So like on the homework. So
Let
like,
me finish this one first. Okay? Polarity. Polar or non-polar? That's the question. Polar or non-polar? You don't need to look at the periodic table for this one.
non-polar.
Non-polar. Because the C and the O is the same thing, isn't it? Well, if you have one C pulling this way with a certain, or one bond pulling this way, one bond pulling this way, is it going to move? No. So this would be non-polar. Anything that is 2, 0, as long as the 2 elements are the exact same, are non-polar. Okay? Go ahead, Marshall.
I was just saying on the homework, so like for the Lewis structure, we're gonna have to probably write it down on paper, take a picture or something.
Yeah.
But then like from molecular geometry, you want to draw that.
I would
Draw
put that.
shape, but I put the name of it on the.
I want both things on that. I want both things on that. When I pull your homework up here in a few minutes, I will try to break some more examples. I'll do that. All right, let's do another one. Let's do NH3. NH3. That's 8 valence electrons. I think that's a question in the homework. 8 valence electrons. N has 5. So 1, 2, 3, 4, 5, 3 H's. So that's my Lewis structure, correct? How many bonded atoms do I have? 3. How many lone pairs do I have? What's the shape? Trigonal pyramid. No. Because tri-period could be trigonal planar, trigonal pyramidal. Come on the back. Got some biopyramids on. All right, so let's draw this, okay? Now you're going to notice. Take me a second to switch all my screens out again. Take me a second to switch your word. All right, so I'm going to go down. I found 3-1, didn't I? I wish I could actually zoom this in a little bit. Right here's 3-1. Ignore that circle. Right here's 3-1. If you look at it, you'll notice that there's a straight line, one straight line, correct? But there's another thing that's kind of a darkened one, another thing that's dashed, okay? And one thing that's dark and one thing that's dashed. That does matter, okay? That does matter. I'm going to draw it the exact same way. I'm going to draw it the exact same way that it is on there. All right, so, what? Yes, we'll get those in just a second, okay? Good question. All right, so now I'm going to get my paper, and I will give you this paper on your test, okay? You will have access to this paper on your test. I know I didn't give a Lewis structure quiz today. It was just too hard for me to do with virtual kids. So, my A on this is what? N. So I'm going to draw my N. I'm going to draw my lone pair of electrons up here, aren't I? I have an H coming up this way. And then I have two different things here, okay? I've got a solid triangle, like that, and it's solid, with an H. The other thing's hard to see, okay? But it's dashes. And notice the dashes get smaller as you go away from the central atom, okay? That's the same thing, okay? That's a hard thing to see with the resolution on this, okay? That's what it should look like. My last question I had was polarity. Polar, non-polar. Is it pulling the exact same? In the exact same directions?
No.
No. So this would be polar. The solid, that's an excellent question you're asking, Darian. That's an excellent question. I'm going to answer that on my next one I do, okay? All right, let's do CF4. 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 So that's going to be 32 valence electron. C is going to be in the middle. That's it. That's a Lewis structure. Okay, that's the Lewis structure. Atoms bond or bonded atoms. Lone pairs. Zero. We're looking at the central atom. Shape. Tetrahedral. Okay, and then polarity, we'll come back to that in just a second. Okay. So, Darian asked a great question. Okay, good job, Darian, asking a good question. I wanted somebody to ask. So, let's draw this one exactly how it's on the paper, okay? I think it is all better. All right, so, exact. So this was 4-0 tetrahedral. I'm going to draw it exactly like this on the paper as soon as my thing pulls up. What? It will last about 5 minutes.
Any of pretty much.
All right, so just like the paper, I'm gonna put my C is gonna be in the middle. F. My C's in the middle. Still not doing very well. My C's in the middle. I had an F going up. When I'm looking at the paper, I had an F going this way. And then continuing the paper, I have a shaded in triangle there and a dashed triangle there. Okay. So Darian asked a very good question. Okay, and I'm gonna try to get up here where I can do it in front of you. Here is your thing, okay? This is the exact same thing I've drawn. Here are my two straight lines, correct? All of these things are in the exact same plane, aren't they? That's what a straight lines represent. They're in the exact same plane. I can make all three of these by taking this one off, touch the board. I touched it wrong one off. Touch the board at the exact same time. Didn't I? That whole okay. What this is then going on, this triangle right here, the solid triangle is telling you if you got a triangle, it's a triangle, and it's fatter next to you, that means it's coming towards you. Okay? This one, dash line, means where's this one going? Going to the back. Okay, does that make sense of how you do that? Okay. So that's what, nobody really uses, I don't really like using these models, okay? We don't have full sets, but that's what those triangles mean. This triangle means it's coming towards you, just like this one right here was. The line means it's going away from you, okay? By the skinnier part being by the F, instead of the F is further away, okay? It's kind of like taking a picture. If you're taking a picture, how do you want to make your head look bigger? Lean forward. You lean forward, your head's going to look bigger. You lean backwards, your head's going to look what? Smaller. That's the same thing we did. My fat part closer to you is bigger. My skinnier part is further away, it looks smaller because I'm leaning back, okay?
So they would stay in that exact same position.
Well, really, another flaw of this is these things are constantly moving, aren't they? They're constantly moving, so all I'm doing is taking a picture at one point in time, okay? But they're always going to be at the same, instead of just being like this at all points in time, it's going to be constantly moving. But no matter how you move it, there's always three that are in the same plane, one coming towards you and one going away from you. All right, next one, let's do IF5. IF5. That's got 42 valence electrons, correct? So my I is the central atom. That's 7, 1, 2, 3, 4, 5, 6, 7. I'll put an F there. Got a problem, don't I? Yeah, I got to expand like that. So I'm going to split some electrons apart, aren't I? Well, it doesn't matter which one of these 6 you split apart. No, I mean, I know that when I'm done, I'm going to have 4 of them. I'm going to have F's on them, 4 of them, or 2 of them that are not. So, that's what it looks like. How many bonded atoms do I have? How many? 5. Somebody say 3?
No.
Somebody said 3. My bad. I have 5 bonded atoms. I have 5 different elements bonded to that. Oh, I didn't answer a question last one. The last one was non-polar. Okay. Lone pairs. How many do I got? 1. Shape. Square pyramid. The last person I'm going to have is polarity, but I'm going to wait till I get finished to figure out my polarity. So I'm going to go find 5, 1. I'm going to draw it exactly how it is. And yep, 5 bonded atoms, 1 lone pair. So my I is the A, so I in the middle. Then I'm gonna have a pair of electrons at the bottom, F at the top, and then I've got 2 of them that are going away from me, don't I? And I've got 2 of them that are coming towards me. What? Yes. Yes. With the flat part of the triangle being through the outer thing. Now, polar or non-polar? Polar. This is polar. What? Yeah, these 2 cancel each other out, don't they? One going away, one coming to you. These 2 cancel each other out, don't they? Nothing to cancel this out, is there? A general rule of thumb, and it's not an all the time thing. Generally, if there's a lone pair of electrons on the central atom, it's a polar molecule. Okay? Generally, it's a polar molecule. Generally, if there are 0 pairs, as long as they're all the same, they are non-polar. Okay? That's not a hard and fast rule, but that's to get you 95% of the time rule. Okay? Especially in this class. Now, let's do one more. Let's do C. This was the one on your homework the other day. CH2O. CH2O. So that's 12 valence electrons. What's central atom? What? Carbon. That's 4 dots, 4 electrons. What am I gonna do now? Where? Doesn't matter. I'm gonna put them there. And then O, does it matter where I put it? 1, 2, 3, 4, 5, 6. Bond, and that's a double bond, isn't it? Oh, how many bonded atoms do I have? No, 3. I have 4 bonds, but I only have 3 different atoms, don't I? 2 H's and 1 O. Lone pairs, 0 shape. Polarity. Polar or non-polar? What? Polar. I just told you that most of the time when they had 0 lone pairs there, non-polar, what was the addendum I added to that? The addendum I added to that. What criteria? Typically, if there are 0 lone pairs, they are non-polar. If all the atoms are the same. Are all the atoms the same on this? No. So that's gonna make it polar, okay? If all the atoms are the same, I guarantee it's polar. All the atoms aren't the same, it's polar. So now let's draw my shape. Now I only have 2 things in here, don't I? I have A's and X's. Does it matter in which place you put your O and which place you put your H's? No, it does not matter. So when I draw it, it's just gonna kind of go like some triangles. C, H at the top, O at the bottom, H at the bottom, like that. Any questions about what we talked about today? Key thing is you can draw your Lewis structures, okay? That's the key thing there. Typically, when I have to say this, I don't really have to look up electronegativity differences most of the time, okay? Anything that is 0 lone pairs, as long as they are all the same, are typically non-polar, okay? Typically, anything with 1 lone pair, typically anything with 1 lone pair is polar, okay? So I'll print out that homework sheet for you. I thought I did. I think some teacher stole it. Oh, perfect timing. And I will, I'll post this video also in case you get lost.